We're going to look at a while loop and an if statement in Mathematica. Mathematica is not as easy to use as Excel. Potentially, for some, it may seem a little bit harder, but it will let you do a lot more, and it provides a really nice introduction, or more than just an introduction, I guess, to computational programming. So what we want to do is we want to flip a coin a bunch of times. We want to flip a coin 1,000 times, no, 10,000 times, and we want to count how many times when we flip that coin do we get a 2, let's say. So we expect we're going to flip 10,000 times. How many times do we get a 2? Well, that would take a long time for us to actually do. But Mathematica lets us generate random numbers and count them very fast. So what we're going to do is we're going to define some variable I, and I is going to be our counter. So it's going to start on 1. So I is going to be our first flip. And then we're going to create, so I put a semicolon here. I'm going to create a counter that counts how many times I get. We'll call it success. So success is going to start at 0. So success happens when I get a 2. Because I want to see how many times do I get a 2. So what I want to do is I want to flip it 1,000 or 10,000 times. So the computational language, the programming language that we're going to use is called a while loop. So I'm going to say while, and then bracket, as long as I is less than 10,000. So as long as I is less than 10,000, comma, what I want to do is create a random integer. So I'm going to say let's create some new value a, where a is a random, and notice that it starts giving me choices here. So I want a random integer, and I want it to be between 1 and 6. Now let me just say what's challenging about Mathematica is that some of the notation you need to get right. What's wonderful about it is that it's really easy to quickly search, go online and just search, how do I do this? Also, we'll give you a bunch of hackable programs so that you can start seeing, what the formatting looks like. But for now, just giving you an example. So going back, so as long as I is less than 10,000, we're going to create a random integer. And what I want to do is I want to see if that random integer is a 2. So I'm going to say x equals, and now I'm going to use my if statement. So an if statement works like this. If it's not x, it's success. Yeah, right. So if my random integer equals 2, comma, what comes next is what I'm going to do if it's true. So if it's true, I'm going to have a 1, and if it's false, I'm going to have a 0. So in other words, I'm going to add 1 if I get it true. So I'm counting how many times I get it true. And then I'm going to add that number, so it's either going to be a 1 or a 0. Then I'm going to add that number to what success had been. So what this is saying is that my new number of successes is going to be my old number of successes plus either 0 if I don't get a 2 or 1 if I do get a 2. And then what I need to do is this I++, which is going to add 1 to my I value. And that closes, so bracket, that closes my while loop. So now, if we think about it, I started with I equals 1 and 0 success. I created a random integer between 1 and 6. I looked to see, did that equal 2? And if it did, I added 1 to my number of successes. And if it didn't equal 2, I added 0 to my number of successes. And then I went down here and said, okay, let's add 1 more to my I, go back up here. So now I would be 2. 2 is still less than 10,000, so I can still do my while loop. And I'll keep running this over and over and over again until I get to an I that is no longer less than 10,000. And when that happens, I break out of my while loop. And then what I want to do is I want to see how many successes did I have. Or maybe more interesting, if I want to find out the probability of getting a 2, what I could do is take the number of successes, so n for a number, and I'm going to take the number of successes divided by the number of throws that I had. And then if I press Shift Enter, and you have to press Shift Enter to run the program. So if I press Shift Enter, it's going to calculate this, and I get 0.1627, and that's really, really close to what I would expect it to be. I would expect it to be 0.166 going on for forever. I could make that even more accurate if I increased the number of flips. So if I went in and changed that to 100,000. So now if I Shift Enter here, I'm getting closer to what I would expect. And if I go a little bit more, this will take some time. Notice it says running up here. That's because I'm doing 1,000,000 flips, but I just did, so 0.167. So that's a really good approximation. There you go.